Hi class, so today's video is the August 14th, 2020 homework. This homework assignment will be due Sunday night, August 16th, before midnight on your team's assignments. So our objective today, guys, is we will determine if a relation is a function and express a relation in multiple ways. So first we need to discuss what is a relation. So when we're discussing relations in math, we're talking about sets of ordered pairs. Okay, and so you might have seen sets of ordered pairs given this type of situation with some type of x and y and given a table. Okay, and we could have numbers all through here. So y'all have seen this represented with tables. Y'all could also see this represented with mapping. Mapping is when we have one set of numbers or one set of any type of integers, whole numbers, any ordered set that we have here that would come to this output over here, and this is mapping. Okay, y'all could also see relationships as far as graphs. So if you saw something like this is a relation. You could even see something like this would also be a relation, right? Okay. And then we could even represent this as far as equations are concerned. So if we gave you something like y equals x squared plus 2x minus 1, this would also be a relation. Now, a lot of times when we see the set or the word ordered pairs, the phrase ordered pairs, we always like to think of a point, some type of x and some type of y. You could say that could be like the point 0, 1, 2, 4, but these are going to be sets, so it's going to be many points. That's a relation, okay? Now let's discuss what a function is. So a function is a relation, but in which each element of the domain is paired with exactly one element in the range. Okay, so what are we talking about here? So remember, x values are your domain values. This is your input. Okay, y values, well, that's going to be your range. And that's your output. So when we discuss the situations where the x values only have one y value, we could discuss a situation like 0, 1, 1, 2, 2, 3, and we'll say 3, 4. We have these points. What I'm going to want to do, guys, and what I'm going to want you guys to do on a daily basis, anytime you see points like this, just to help us frame our mind, I'm going to want you to label our points. X, Y, X, Y, X, Y, X, Y, X, Y, X, Y. And let's check this out. We want to identify our domain values. So our domain values in this case would be all of our x values. So let's check that out. So if we're saying x domain, the numbers in that set of the domain would be 0, 1, 2, and 3. So let's go back to the definition of a function. It says a relation in which each element in the domain, okay, I'm circling that. Let me pick a better color to circle that with. Domain is paired with exactly one element in the range. Y'all have already heard this before, you're all Algebra II students, but in other words, our x values cannot repeat. And in this case, they don't. So with this number set, we would say that this is a function. Those x values didn't repeat. If we have some type of graph on a coordinate plane, and I drew this situation, and I want to explore our domain, well, we would say our domain or x values would be all real numbers in the set, because this would go on for infinity and then negative infinity and positive infinity. And what we're going to notice here is we're going to look at this vertical line test. And that says in order to be a function, a vertical line cannot pass through more than one point in the relation. So what that means is when I draw this vertical line, anywhere through the relation, it's going to only cross it once. Oh, look, it crosses it once there. If I draw it somewhere over here, how many times does it cross? Just once. And over here, just once. So we could say that this is a function. What if I have the situation where I have a circle on our graph? Is this relation a function? We would do our vertical line test. How many times does it cross a relation? One time, two times. This here, not a function. So let's do some more examples, just to really cement this learning in. Given this number set, okay, it says find the domain and range of each relation, then determine if the relation is a function. So to determine domain and range, okay, first I want to label my points. I know this is x and y, x and y, x and y, x and y. And we know that domain has to be our x values. And let's use blue here. Let's say that our y values have to be the range. So let's identify all of our x values for the domain. So we're going to start with our braces, and we're going to say -1, 0, 4, 6. For our y values, those are these values here, those values would be -9, -5, 3, -2. So now that we've identified our domain and range, we need to decide, or we need to come to the conclusion, is this a function? Well, based off the rules, we want to make sure that our x values did not repeat at all in the set. Well, -1 happened one time, 0 is one time, 4 is one time, 6 is one time. So because no x values repeated, in other words, our x values have one unique y value that it goes to, then this is a function, yes. As just a quick guide to this, why is this a function? Well, our x values did not repeat. It's a unique relation, okay? So let's look at our table, and let's determine our domain and range. Well, we know that x is domain, and we know that y is range. So let's go ahead and label this here. We've got x here is domain, and that's going to be all these values here. So in our set, we would say 7, 2, 0, -4. And our range would be all of these values here. And we would say -8, 3, -1, 3. So with the question of, is this a function? Well, you're going to see here, oh, look, I have no repeating values for my x values. This is good. Some students will look at the range and see, oh, look, we have repeating 3's. That does not affect this, not one bit. If you remember our definition, only the x's cannot repeat. No repeating x values repeat at all. So is this a function? Yes. Why is it a function? X values are not repeating. Let's try another one. So let's look at this here. And so we have all these points scattered on this table here. Let's go ahead and label our points. So this first point right here, this is going to be at 1, 2, 3. So -3, 1. This point over here would be at -3, -2. This point up here would be at 0, 1, 2, 3, 4. This point right here would be at 2, -1. And this point over here would be at 1, 2, 3, 4, 1, 2, 3, 4, 5. So this would be 4, -5. Okay, so we have all these points. When we're determining our domain here, so domain we're going to say is x. We want to identify all of our x's. Well, here's an x, so we'll say -3. Here's another x, -3. We have another x over here at 0. We have another x here at 2. And our other last x value here at 4. Our range value is our y's. Here's a y value at 1. We have another y value here at -2. Another one over here at 4. Another one here at -1. And our last one here at -5. Okay. So is this a function? Well, we want to check our domain values. We want to ensure that none of our domain values or our x values are repeating. So I have -3, -3. Oh, I can stop there. Our -3 values are repeating. So is this a function? No. We're also given this as a graph, so we can actually do a vertical line test. And when I draw a straight down vertical line through here, we see that that vertical line is crossing this relation at 2 points. So that only further emphasizes that number 7 is not a function because the x values repeat and it fails the vertical line test. Let's do one more. So we're looking at this problem here, and this one's a little bit more difficult to kind of identify. Like, what is our domain? Well, our domain is going to be our x values. So we know we're going from x values from here at -2, and we cover the entire area all the way over here to 1, 2, 3, 4, till 5. And this is including like every little value in between. So from -2 to 5. So our domain, and we're going to go ahead and represent this as our x value, okay, which is going to be less than or equal to 5, but it's also going to be greater than or equal to -2. So we're going to express this with inequalities because we're talking about all of these values in between -2 and 5. Okay, so all these numbers between, we could say it's -1, 0, 1, 2, 3, 4, 5, 1.5. Everything between -2 and 5 is our domain. Same idea works for our range. Let's think about our range. What is the lowest our graph goes? The lowest our graph goes is right here at y equals -2. The highest it goes is right up here at y equals 1, 2, 3, 4. But it's touching all these points infinitely, okay, between 2 and 4. So we would say that our y value is less than or equal to 4, but it's going to be greater than or equal to -2. So when we're looking at this, it's like, okay, like how do I determine if my x values repeat? And that's where it gets a little tricky. So with this here, I would definitely just use the vertical line test. I can draw a vertical line straight through here, and it crosses the circle, or this round figure, twice. Because it crosses twice, it fails the vertical line test. So is this a function? No. So the answer to number 10 No, it's not a function. Why? It fails the vertical line test. Let's go ahead and move on to the next problem. Okay. Y equals negative 5x minus 1. Oh, how do we do that? All right, so you're going to take this equation, and we're going to be using Desmos.com. You'll see here that Desmos.com, we went ahead and graphed this in there, and it gave us this graph. And we're going to be using this software a lot more this year. But given this graph, you'll see that this line, and it doesn't clearly represent it, but it's going on infinitely. This is a linear function here. Hint, hint, linear function. Okay? And we're talking about domain. So how far to the left, or how far in this direction is it going to go as far as domain? Well, we'd be going to the negative infinity, right? How far to the right is our graph going to go? Well, if this goes on forever, it's going to go forever in the positive infinity. Okay, so we could say negative infinity, positive infinity, or this would be all real numbers. Let's talk about the range. Ranges are y values, so how far down is this going to go in the negative direction? Well, this graph, if we just let it go forever, it'll go down in the negative infinity direction. How far up will it go? It'll go up in the positive infinity forever. So we'll say negative infinity to infinity, which is also going to be all real numbers. So is number 12 a function? Well, is there anywhere that I could draw a vertical line test that would cross this line more than once? Well, here's just one time. Here's just one time. So no, it only crosses one time. So is this a function? Yes. This is a function. More importantly, it's a linear function. So this is going to be the end of our video today, guys. We will be doing some more practice problems when I see you next time in class. Hopefully this video helped, and I look forward to seeing you guys soon. Have a good day.